In this video, we'll focus on the discussion of thermochemical equations. As you observe here, this thermochemical equation is composed of the balanced chemical equation with the additional data or information. This one is the change in enthalpy or delta H. Delta H is equal to the heat absorbed or released during a chemical reaction. Of course, heat is a form of energy, so energy can be absorbed or released during a chemical reaction, and this energy is in the form of heat. So we have two types of chemical reaction. It can be endothermic or exothermic. Endo means inside, so these reactions will absorb energy, while exothermic reactions, they releases energy. So in this reaction here, H2 plus Cl2 producing H2Cl. Delta H here is negative 185 kilojoules. So here delta H is negative, meaning that here in this reaction, in the formation of HCl, energy is released, and the energy again is equal to 185 kilojoules. And of course, this energy is released in the form of heat. So again, the change in enthalpy is equal to the heat absorbed or released during the reaction. So let's examine this sample equation here. So let's consider this one. We have A2 plus B2 producing 2AB, and here delta H is equal to negative 100 kilojoules. Note that this delta H here is specific to the given molar quantities in the balanced chemical equation. So delta H is this value when there's 1 mole of A2, then 1 mole of B2, and then 2AB are produced from the reaction. So what if we have 2 moles? Okay, 2 moles of A2. What do you think is the value of delta H? So it says here that for every 1 mole of A2, negative 100 kilojoules uh, are released from the reaction. So if we have 2 moles of A2, then delta H is equal to negative 200 kilojoules. So as you observe here, when we double the amount of the substances, we also double the delta H in the reaction. Let's go to B2. So let's say instead of 1 mole, we have 2 moles. Okay, 2 moles of B2. What do you think is the value of delta H? So as you observe here, for every 1 mole of B2 reacting, delta H is negative 100 kilojoules. So if we have 2 moles, then delta H is equal to negative 200 kilojoules. Next, what if we have 2 moles? Okay, 2 moles of AB, that is the product in this reaction. What do you think is the value of delta H? So as you see here, for every 2 moles of AB, then we have delta H is equal to this value. So since we have 2 moles here, then delta H is equal to negative 100 kilojoules. So again, just look on the numbers in our thermochemical equation. Let's say we have 4 moles. Okay, 4 moles of AB. So 4 moles of AB. What do you think is the value of delta H in the reaction? Of course, 4 moles is double the amount of 2 moles. Then we should also double the amount of, or the value of delta H. Therefore, for every 4 moles of AB, then delta H is equal to negative 200 kilojoules. Let's examine another sample chemical equation. So here we have, okay, let's go back by the way. So here it's negative, so this one is also an exothermic reaction. So exothermic reaction. So here we have another reaction, C2 plus D2 producing 2CD. So this reaction, the delta H is equal to 50 kilojoules. So here delta H is positive, therefore this reaction will absorb heat from the surrounding, and again the amount of heat needed for the reaction is 50 kilojoules. Okay, let's answer the first one. Determine the amount of heat absorbed when 2 moles of C2 are used in the reaction. So let's go back and analyze the thermochemical equation. So here, the coefficients are 1, 1, and then 2. So if we interpret this one, for every 1 mole of C2, delta H is 50 kilojoules. For every 1 mole of D2, delta H is also 50 kilojoules. And then for every 2 moles of CD, delta H is equal to 50 kilojoules. So here, what if we have 2 moles of C2? So 2 moles of C2. What do you think is the value of delta H? Of course, it's very easy. So if we have 1 mole of C2 is 50, then 2 moles of C2 is equal to 100 kilojoules. So this time, let's make it um, organized. So on this case, we'll use a conversion factor. So on this case, again, we'll try to convert mole of C2 to the amount of delta H. And for the numbers here, just look on the thermochemical equation. So here the coefficient is 1. So here for every 1 mole of C2, what is the delta H? So here delta H is equal to 50 kilojoules. And then I think we're ready to solve this one. So that's 2 times 50, it's equal to 100 kilojoules. Okay, so the answer for this one is 100 kilojoules. So when 2 moles of C2 are used in the reaction, then 100 kilojoules of heat is absorbed in the reaction. So the unit is still kilojoules. Note that heat is a form of energy. So this is still the unit for heat in this problem. Let's go to the second problem, or the second question here. Determine the amount of heat absorbed when 4 moles of D2 are used in the reaction. So again, 4 moles of D2. And then we'll find out the amount of heat absorbed. And again, the heat is equal to delta H. So here, the moles of D2. And then let's look on the thermochemical equation. The coefficient here is 1, so let's put 1 here. Now for every 1 mole of D2, delta H is equal to 50 kilojoules. 50 kilojoules, and I think we're good. So 4 moles, mole of D2 cancel. What's left is kilojoules. Then 4 times 50, it's equal to 200. So here, when 4 moles of D2 are used in the reaction, 200 kilojoules are absorbed in the reaction. Next, determine the amount of heat absorbed when 4 moles of CD are produced in the reaction. The same thing, 4 moles of CD. And then, let's look on the thermochemical equation. So here, moles of CD. Then here, the coefficient here for CD is 2. Let's put it here. So for every 2 moles of CD, delta H is equal to 50. So that's 50 kilojoules. Mole of CD cancel. What's left is kilojoules. And then let's solve this one. 4 times 50 to 100 over 2. So that's equal to 100 kilojoules. So the answer for this problem is 100 kilojoules. Let's go to another one. This time it's a real thermochemical equation. So here H2 plus Cl2 producing 2HCl. Delta H is equal to negative 185 kilojoules. So here delta H is negative. So therefore, in this reaction, energy is released. And again, the energy that is released from the reaction is this one, 185 kilojoules. And then the energy is released in the form of heat. Let's go to the first problem. Determine the amount of heat released when 2 moles of H2 are used in the reaction. So here, let's do the same thing kanina. So let's write the given 2 moles of H2 and then find out the amount of heat released. Again, the amount of heat released is equal to the delta H. So in this case, a mole of H2, and then for the number here, look on the thermochemical equation. So here the coefficient here for H2 is 1. So for every 1 mole of H2, delta H is equal to this value. So that's negative 185 kilojoules. Okay, then after this one, we're ready to solve this one. So moles of H2 cancel. And then let's use our calculator. So that's 2 times negative 185. So here that's 370. So negative 370 kilojoules. So on this one, so when 2 moles of H2 are used in the reaction, then 370 kilojoules are released from the reaction. Let's proceed to the next one. Determine the amount of heat released when 4 moles of Cl2 are used in the reaction. So here 4 moles of Cl2. Then determine the amount of heat released. The same process. So moles of C2. Sorry, this one is Cl2. Cl2. And then here the number or the coefficient is 1. And then for every 1 mole of Cl2, delta H is equal to negative 185 kilojoules. So it's negative 185 kilojoules. And so let's solve this one. So that is 4 times 185. That's equal to 740. So 740 kilojoules. So when 4 moles of Cl2 is used in the reaction, 740 kilojoules is released from the reaction. Next, determine the amount of heat released when 4 moles of HCl, that's the product here, when 4 moles of HCl are produced in the reaction. So the same thing, 4 moles of HCl, and then again the moles of HCl. For the number, just look on the coefficient in the thermochemical equation. That's 2 mole of HCl. And then for every 2 moles of HCl, delta H is negative 185 kilojoules. Negative 185 kilojoules. And then let's solve this one. Okay, that's 4 times 185. And then we'll divide it by 2. Divide it by 2 is equal to 370. So this one is negative 370 kilojoules. So when 4 moles of HCl are produced, 370 kilojoules are produced in or are released by the reaction. Okay, let's proceed to this one. So this is similar to the previous one, but here the given is in the form of the mass. So, but here in the previous one, we started with the mole. So obviously the first thing we need to do is again to convert the grams into the number of moles. So let's start with the given 4.04 grams of H2. So what is the amount of heat released by this reaction? So again, first convert the grams into the number of moles. So from grams of H2 to the moles of H2, 1 mole of H2 is equal to how many grams? So let's determine again the molar mass of this substance. So here for hydrogen, let's check our table of elements. Hydrogen, the mass is 1.01. 1.01. Then here we have H2, so it means times 2 is equal to 2.02. So the molar mass of H2 is 2.02. So 2.02. So right now, we have converted our mass into the number of moles. And after this one, we can proceed with the normal process. So we'll find out how many kilojoules will be released from the given amount of moles. So here again, the moles of H2. So let's look on the thermochemical equation. So here 1 mole of H2, delta H is negative 185 kilojoules. So that's negative 185 kilojoules. Then I think we're good with our setup. So let's do the math here. So that's 4 times 185, 740 divided by 2.02. Divided by 2.02. The answer is equal to, right, let's check muna. 4.04 times 185 and then divided by 2.02. The answer is equal to 370. So this one is negative 370 kilojoules. So when 4.04 grams of H2 are used in the reaction, then 370 kilojoules are released by the reaction. So again, release, so it's negative in our answer here. Let's go to the second one. So it's still in mass. So the first thing is to convert the mass into the number of moles. So we have 283.6 grams of Cl2. Again, the first thing is to convert to the number of moles. Gram of Cl2 to the mole of Cl2. 1 mole of Cl2 is how many grams? So let's do again so let's determine again the molar mass of Cl2. If you check your table of elements for Cl, the mass of Cl is 35.45. 35.45 and then Cl2, so meaning times 2. So that's 35.45 times 2, that's 70.9. So the molar mass of Cl2 is 70.9. Let's put it here. So 70.9. So we have converted the grams into the number of moles. And then after that one, we'll proceed in determining the heat released by the reaction. So again, that's the mole of Cl2. And then for the numbers, just took on the equation. So that's 1 mole of Cl2. And then for every 1 mole of Cl2, delta H is equal to negative 185 kilojoules. Negative 185 kilojoules. And then we're good with the calculation. So that's 283.6 times 185, and then we'll divide it by 70.9. Divided by 70.9, the answer is equal to 740. So that's negative 740 kilojoules. So for this item, 740 kilojoules of energy is released by the reaction. Next, determine the amount of heat released when 145.84 grams of HCl are produced in the reaction. So the same thing, 145.84 grams of HCl. So again, grams na po. So we'll convert the grams into the number of moles. So grams to the number of moles of HCl. 1 mole of HCl is how many grams? Let's again determine the molar mass of HCl. So this process is repeating over and over again. So I hope you have learned about our discussion on moles in the first semester. So we have here H and then Cl. The mass of H, that's 1.01. And then for Cl, that's 35.45. Just check your table of elements. Then we add all the masses. 1.01 plus 35.45. That's 36.46. So 36.46. This one is the molar mass of HCl. So 1 mole of HCl is equal to 36.46 grams. So after converting the grams into the number of moles, we'll go with the usual process. So the mole of HCl. For the numbers, look on the equation. So here we have 2. So for every 2 moles of HCl, delta H is negative 185 kilojoules. Okay, then we'll solve this one. Let's first multiply the numerator here. So that's 145.84 times 185. Okay, that's 2698 26980.4. That's a first negative. Then we'll multiply 36.46. 36.46 divided by 2. I mean times 2 rather. 36.46 times 2. 72.92. 72.92. So that's, let's solve it again. 26,980.4. 26,980.4 divided by 72 point, okay, 72.92. 72.92 is equal to 370. So here the answer is 370 kilojoules. And of course that's negative because here the heat is released by the reaction. Okay, so this one is from the book. So we have CH4 plus 2O2 producing CO2 plus 2H2O. This reaction, so delta H is negative 890.4 kilojoules. So here delta H is negative, meaning energy is released by the reaction. So, and again, the energy is 890.4 kilojoules, and this energy is released in the form of heat. So the question here is determine the amount of heat released when 31.5 grams of CH4 are used in the reaction. So let's start with the given 31.5 grams of CH4. So I guess it's the same from the previous questions. So again, it's grams, but we need to first convert the grams into the number of moles. So grams of CH4 to the moles of CH4. 1 mole of CH4 is how many grams? With this one, we need to determine the molar mass of CH4. For carbon, that's 12.01. Hydrogen, 1.01 times 1 times 4. 12.01. Then this is 4.04. Okay, so this one is 16.05. So the molar mass of CH4 is 16.05 grams. Then after converting the grams into the number of moles, we'll go with the finding out the delta H here, or the heat released from the reaction. So here that's mole of CH4. And again, for the numbers here, just look on the thermochemical equation for CH4. The coefficient here is 1. So 1 mole of CH4. For every 1 mole of CH4, delta H is this one. So that's negative 890.4 kilojoules. And we're ready to solve this one. So that's 31.5 times, okay, 31.5 times 890.4, and then we'll divide this one by 16.05. 16.05. The answer here is 1000, okay, 1000 1747.51, okay, 0.51 kilojoules. And don't forget the negative sign because this one is an exothermic reaction.